Hey guys, Mr. Middleton here. Today we're going to talk about applications of radicals. At the end of this video, you should be able to apply radicals to find side lengths of triangles. Alright, one theorem that we've seen before that uses radicals is the Pythagorean theorem. We call it Pythagorean's theorem, but Pythagorean theorem. Okay. Alright, and this theorem goes like this: a squared plus b squared equals c squared. Okay, this theorem can only be used with right triangles. And the side that is opposite the right angle is called the hypotenuse. Okay, that is the side that will be C. The other sides don't matter which ones you use. And this is always the longest side. Okay, the hypotenuse, always the longest side. Okay, the other sides are called legs. So let's go through some practice problems using this familiar theorem. So let's find the length of the hypotenuse in a right triangle if the legs are 4 centimeters and 6 centimeters. Leave your answer in simplest radical form. So I like to draw my triangles out, especially anytime they give me a description. I think it's helpful to have that out. They tell me that the legs are 4 centimeters and 6 centimeters. They want us to find the hypotenuse. Remember, that's the longest side opposite the 90-degree angle. And so I have an equation. I can say 4 squared plus 6 squared equals c squared. Okay, this is Pythagorean's theorem. So now I'm going to simplify these. Get c squared equals 52. Oop, that's c squared. Okay, and so in order to find out what c is now, I need to take the square root of both sides. Okay, so square root of 52, I'll do my tree. It's 13 times 4. 13's prime, 2 and 2. So c will equal 2 radical 13. Alright, let's do some more problems. Let's find the missing side length in each right triangle. Leave your answer in simplest radical form. Alright, quick warning, you cannot just use a squared plus b squared equals c squared and just plug in numbers however you like. Remember that it is important for you to remember that the hypotenuse is c. You need to make sure that you put the lengths where they belong. So for number 1, we're given these 3 sides. I'll call this A, I'll call this B, I'll call this C. Okay. Typically what happens is people see 2 numbers and say 9 squared plus 12 squared equals B squared. It's not how it works, okay? So I'll say 9 squared plus our unknown B squared equals our hypotenuse 12 squared. So 81 plus B squared equals 144. Subtract 81 from both sides, so give me B squared equals 63. Okay, and now to find b, I need to take the square root of both sides. So the square root of 63, that's 7 and 9. 7's prime, 3 and 3. 3 radical 7. Okay, so the side length in simplest radical form is 3 radical 7. Alright, number 2 is tricky, but just because they're using radicals, okay? We've been dealing with radicals enough that hopefully we're able to do these without too much issue. Okay, again, I'm going to go through and just for myself, make sure I label my sides. 5 radical 7 squared plus x squared equals 5 radical 13 squared. Okay, then I square these. 25 times 7, that gives me, well, times 4 is 100, so 175. Okay. So, because that'll give me 25 times radical 49. Okay, and radical 49 is 7. Okay, I'll just leave this as x squared, and this will give me 25 times 13. I'll do that as a calculator. 25 times 13, 325. Okay. Alright, so this is 325. And so, now I will subtract 175 from both sides in order to get my number by itself. That gives me 150. And so now to find x, I need to take the square root of both sides. 15 and 10, 5 and 3, 5 and 2. So I have a pair of 5s. That will go on the outside, and then 2 and 3 with no pair, they stay on the inside. Multiply those together, gives us 6. Okay, so that missing side is 5 radical 6. Okay. Alright, more problems on the back. says find the area of the triangle below, give your answer in simplest radical form, then round to the nearest 10. Alright, so the area of a triangle, remember, is area is 1/2 base times height. So for this problem, they already gave us our base. Our base is 15. We need to find our height. We're going to find our height in this case by using Pythagorean's theorem. Okay, and that's again, a squared plus b squared equals c squared. Okay, x squared plus 15 squared equals 21 squared. So x squared plus 225 is 441 if I'm right. Make sure I am. Sure, 21 times 21. 21 times 21 is 441. 15 times 15. Okay, so 441 minus 225 gives me 216. So x squared equals 216. I'll take the square root of both of these. That will give me x equals, I know 6 goes in that. 6, and that's 3, 6. Alright. Alright, so I could break this down further into 3 and 2, but there aren't pairs there. So x, the height then will be 6 radical 6. Okay, I want to make sure that I remember that they're asking me, sorry, height 6 radical 6. So they're asking me for the area. Again, area is 1/2 base times height, so 1/2 6 radical 6 times 15. Okay, and now I'll multiply across. I'll do 1/2 times 6, which gives me 3. Alright, 3 radical 6 times 15, and that should give me 45 radical 6. So the area is 45 radical 6. Okay, now it says area rounded because they want me to use a calculator for it. Alright, so I can do radical 6, okay, times 45, and that gives me 110.2. Alright, so I can do both. Alright, finally, we have this last problem. We have 2 radical x, 3 radical 6, 4 radical 5 in a right triangle. We need to find the value of x. Basically, we're asked to find Pythagorean's theorem just a little bit. Okay, so our 2 legs, 2 radical x squared plus 3 radical 6 squared should equal 4 radical 5 squared. Okay, squaring these, that'll give me 9 times 6, which is 9 times 6, which is 54. This will give me 4 times x, and this will give me 16 times 5, which is 80. Okay, so now what I'm going to do is I'm going to subtract 54 from both sides. Gives me 26. All right with that, 26. Yep. So I'll divide by 4, and so x will equal 51. Nope. Sorry. Wow. Not 51. 5 point. Nope. 6.5. Wow. Okay. I'll do that on a calculator just so you believe me after I messed up so many times. 26 divided by 4. 6.5. So x equals 6.5. Alright. Okay, cool. So, there you have it, using radicals and applying them to other things. A lot of times we're using Pythagorean's theorem, and you'll especially need that next year in geometry. Being exposed to this will be helpful. Alright, see ya.